All right. Well, it looks like we have a critical mass. We'll jump into it. Good morning, afternoon, evening, whichever part of the world you're joining us from. Welcome to our third episode in our ongoing series on the future of AI governance. My name is Peter Stockberger. I'll be moderating the discussion today. I'm a partner with the law firm at Dentons, where I help co-lead our global AI efforts. With me are three esteemed panelists. We've got Capum Peterson, co-founder and chief innovation officer at Verses, Philippe Sayeg, who is the chief adoption officer at Verses, and George Percival, who is an engineering fellow at the Spatial Web Foundation. We wanted to run this webinar today as we head into the holidays to further the conversation around AI in the public policy and in the governance space. I think we can all agree that there's been a lot written, a lot said about AI, and there's a lot of noise about what really matters around AI. And our goal for today's discussion is to dissect some of the material concepts in the public debate, obviously picking up on the news from Friday with the political agreement around the EU AI Act, but also looking ahead at the global development of international standards, of the development of public-private sandboxes that a number of countries, including the US and the EU writ large, are looking at, and really help put an arrow in the direction of where we're heading from an AI standpoint as we move towards artificial general intelligence. So that's the table setting of why we're here and what we're going to talk about. But before we jump into the meat of the substance, I think it's always helpful in these discussions around AI to start with definitions and concepts, but not too basic, because I think we're all familiar with the general concept of AI at this point. But Capum, I wanted to start off with you and actually unpack some of these phrases and terms that we're starting to see more and more in the headlines around foundation models, obviously LLMs, but the broader discussion around artificial general intelligence and the difference between narrow intelligence in general. So Capum, I was hoping we could start off with you and unpack some of these concepts and what folks in the audience should understand as we read the fast developing headlines and look at the public policy debate forming.
Yeah, you bet. Thanks, Peter. So yeah, I mean, there's been a lot of hype recently in the last year with LLMs, and we probably wouldn't be having this discussion if it wasn't for everything that's been coming out recently. So foundation models, basically, that's the driving under structure for these large LLMs to be able to actually, make decisions and try to come back with some sort of reasonable answer. LLMs, basically, it's like a gigantic kind of prediction machine. It's trying to figure out what the next thing is going to be, whether that be a word or a pixel, and they're incredibly complicated. And so there's some challenges with them. One of the main ones is that they're very opaque. You don't actually understand why it's making the decision that it's making. And this is one of the challenges, especially in the age of AI and regulation. You need to understand why it's making the decision that it's making. And also they tend to hallucinate and they have very bad accuracy problems. So that's why you see there's not a lot of companies actually deploying this in the real world. And because they can't really rely on the answers they're getting. And they're very narrow. They don't really understand like a broad sense of the world, and they actually don't really have any true intelligence or comprehension of the world. They don't understand the context. They can't really reason. They're really just trying to give you like what they think the next thing that you want to see is. They're also only trained on the past, which is another challenge. They don't really know what's going on in real time, and they certainly can't predict what's going to happen in the future. And so what you really need is you need an AI that can learn and understand and reason and kind of know what it knows and knows what it doesn't know and go out and try to find that information. It sounds a little bit scary, but we can talk about how do you make sure that that's safe. And for me, I think one of the biggest concerns I have is the environmental challenges with it. They're talking about these take so much energy to run these models that they're actually talking about hooking up nuclear power plants to run them. So something doesn't sound right when you say that, right? I mean, your brain is only 10 or 20 watts. And if you need a nuclear power plant to run an LLM, then it seems like we're probably on the wrong approach. And recently, as many people know, Geoffrey Hinton's Google DeepMind, he is actually the godfather of most of these approaches that you're seeing in the LLM and AI world. And so that tells you another thing that we're certainly on the wrong trajectory here. And what they're really trying to get to is AGI. And so AGI is artificial general intelligence. That means it's actually it can reason and comprehend like a human. It's actually has sentience. The belief is that the LLM approach is not to be able to achieve that. And Sam Altman recently came out and said that over at OpenAI, that they needed a breakthrough, and that's something that Versus is working on, is that breakthrough. We have something that's called natural intelligence. This is led by Dr. Carl Friston on our team, and our team of engineers and researchers. And this is a natural way that the brain actually understands and comprehends the world. It's based on something called active inference. It's how the brain, it makes predictions about the future, it senses what's in the world, it then updates its beliefs on that, and it goes out and does it again. So it's actually predictive and understanding the world, and it learns. And so that's the natural approach that Versus is on. We think that that's really the true approach to AGI.
So Capum, is it accurate to say then that there's the LLMs, and I guess which are an offshoot of the foundation models? The foundation models are foundations created by certain companies, and then LLMs are an offshoot of that. These are just the tip of the iceberg in terms of the capabilities of AI, and they're getting a lot of attention because they're being used commercially and they're readily available in browsers, and there are real world impacts that are being seen now. But Captain, to try to recapsulate what you just said, is the future not LLMs of AI in your view? Is it more of this ecosystem of agents and networks of AI versus these larger models? And the reason why I asked for that clarification is because, and we'll talk about this shortly, in the EU AI Act, at least in the announcement on Friday, there is some focus on computational power in terms of the regulation. We also saw that in the executive orders, the White House's executive order on AI, reference to computational power. So I'm just curious on this distinction between LLMs and different forms of AI, where you see that in the conversation.
Well, yeah, LLMs, and also, I mean, if you guys saw what Gemini came out with Google, it's very multimodal, so you can give it, video and images and sounds. All the sensors are coming to it. Those are all incredibly useful as we scale up AI, because you need to understand the world. But it's what does you actually do with that understanding that's really important. And as we're going in towards something that's more distributed and more specialized, every industry has a very particular need when it comes to AI. And so you need to really understand the use cases, what are the security protocols you need, what are the risks associated with it. It has to be very distributed and specialized. Every AI in the future, or AGI in the future, I believe is going to be specialized to really target and address a particular kind of challenge, but they need to be interoperable. They need to be able to share information with each other, and so it can holistically try to address these challenges.
So I think, Cabum, that distinction, and George and Philippe, I want to bring it to you here to talk about really what's at the top of everyone's mind right now from Friday, is this announcement that we have a political agreement on the EU AI Act, a first of its kind regulatory framework for the European Union on regulating AI. And Capum, to your point, there is a focus in the at least draft text and the political announcement around the difference between LLMs and foundation models and general artificial intelligence. But George and Philippe, I wanted to get your thoughts on this announcement of a political compromise. We don't yet have the final text in front of us, but we do have the high-level touch points. There is an agreement that certain LLMs, certain large models, will face stricter scrutiny under the law. We do have a risk-based approach based on use cases, and there are some enhanced transparency requirements that were announced. So, Philippe, I want to toss it over to you to get your top-level thoughts and items that stuck out to you from this announcement. Oh, Philippe, I think you're on mute. Yep, still on mute, Philippe. But Philippe, while Philippe comes off mute, George, I want to maybe kick it off with you. What stuck out to you in the announcement itself?
Yeah, thanks, Peter. And of course, it is great progress to have these discussions at these levels and to make advancement about common terminology and the like, as in the AI Act, or where it's headed right now, as you say. My comment about it would be kind of twofold, though. One is this focus on LLM and large models. The other is the governance and the bureaucratic response to governance. may not be enough. So on the LLM side, one of the negotiators in that communique, in the press releases, the comment was that the most powerful models will become the basis of all AI. And so that gives you a real clear indication of the focus of the act, right? It also calls out the OECD definition of AI, which is really good, except it doesn't really address the autonomy of AI and having goals and the like. So, these approaches, this focus on these two things may lead us to some unsafe and untrustworthy systems where you've got small, lightweight APIs in safety critical applications. That's already happening. It's going to happen more. There's also, the AGI and the need for autonomy and understanding how AIs define their own goals and change them. And so, how do we understand AIs in that kind of a way when they're embodied in the real world? And that's an approach that the Spatial Web is really going after, the Spatial Web Foundation and the SPEC. On the governance topic, the call out there is for several committees or offices. There's an AI office, a scientific panel, an AI board, an advisory forum. These will be wonderful places and fora for understanding a broad set of discussions, but they need to be broader. The conversation needs to go beyond government bureaucratic committees, and that's where technical innovation needs to be fostered by open standards. The US executive order, for example, called out that the government should develop best practices, and contribute those to the open consensus standards. And so that's an approach that probably the EU needs to take on as well. I know they have in the past, maybe they will in the future. I am optimistic that the EU Act really updates, it seems, its definition of its regulatory sandboxes, where they're now really talking about development, testing, and validation in real world conditions, and learning from that implementation in a broad arena of folks interacting to inform what the government requirements and the regulations will be is really optimistic to see. So those would be the kind of two main comments I'd have, Peter. Thanks.
Philippe, so I want to bring it over to you for your top line items in the announcement from Friday that stuck out to you.
Yeah, so the AI Act is definitely has progressed, and we have reached some consensus there, which I think is optimistic to continue on that thread. The couple of points that stuck out to me was obviously the tiered risk-based approach has been maintained. So you have like AIs that are considered having unacceptable risks like biometrics, social scoring, behavioral control have been just banned. Some are requiring regulation and the need for certification. They're qualified as high-risk AI. So you have autonomous vehicles, personal profiling, and the rest. Medium risk AI, and we've been talking about foundational models and Gen AI, fall under that category where there's no banning and no need for certification. However, there is a need for transparency and IP protection. And then there's a low and medium category that do not require much regulation there. They fall under the category, for example, of recommendations in e-commerce and entertainment. There's a sanctions side to this as well, where you have penalties that are ranging from 7.5 million to 35 million and or 1.5% of the revenue to 7% of the revenue. So this is very interesting, and it's quite amazing to get that number or that amount of countries to converge around a common policy. However, it is worth noting that this legislation, like many others regarding AI right now, leans more toward remedial actions as opposed to preventive measures. And so while there are rules and sanctions that have been set, the aim is still to regulate the people, the organizations, and the data, right? So two things particularly come to mind with respect to that. One is that the issues of explainability in the decision-making process and the recommendation process remains unsolved. And this is foundational to be able to understand why AIs behave the way they do. And then you have a liability issue that's still unsolved as a consequence. And when you start looking at this from an operational level, as opposed to, for example, compared to large language models that are focused on creation, and creativity and automating simple processes, the compliance of the behavior of the algorithms and the network to the policies becomes critical, because in real world AI operations, you need to be able to make sure that the decisions that have been made, the behavior that has been allowed is compliant with legislation. And in autonomous, you can't run smart cities and autonomous mobility on LLMs, right? So you can push it even further. We need to be in a position where a government decides to shut down an AI if it's going rogue. So the AI governance approach needs those technological tools, and the Spatial Web Foundation provides those social technical standards that allow to enable these capabilities.
One other, I think, important takeaway around the EU AI Act for folks on this webinar is timing. What we had announced on Friday is an agreement around what is going to be in the text of the actual regulation. That text has not been released yet. So we actually haven't even seen the nuts and bolts of how this agreement is going to be operationalized. And following that, it still needs to be passed. And then there will be a grace period on implementation. And so we're seeing some discussion about a 6 to 24-month grace period, depending on the tool. Potentially this law not taking effect until 2025. And we can only imagine, Captain, bringing up what you talked about with artificial general intelligence, what's going to happen between now and 2025. So we're still very much in a known unknown state as to how this law, I think, will impact the development of technology. But Philippe, I wanted to pick up on a thread that you just opened up, which was this distinction between regulating people versus regulating technology versus regulating the network upon which the technology sits. And to me, that's a very important debate because, as you noted, Philippe, a lot of the laws being developed at the moment, including on the US side, are focusing on regulating people and organizations. Be responsible, be transparent, be fair in your deployment of AI. We're starting to see, at least this is my view, in the EU AI Act, as well as some mention in the White House executive order, an attempt to regulate the technology itself by calling out specific computational models and limits. But what we haven't seen as part of the debate, and this is what I wanted to get all three of you to comment on, is a discussion about the network upon which all this technology is going to sit, which I know we oftentimes refer to as the spatial web. But am I understanding that debate correctly? Because I think that's an important top line, people versus technology versus network, is an important part of the public policy debate that we're seeing. And George, maybe I'll toss it back to you, since I know you're heavily involved in the Spatial Web Foundation. What are your thoughts on that framing of the debate?
Absolutely. And so what we've seen a lot of, of course, in government negotiations and discussion is what can the government do, right? It's wonderful discussion. What we also need to bring forward is what can the technology industry do, along with government, along with researchers, in terms of getting us to a safe and trustworthy ecosystem of AIs, embodied AIs in the ecosystem, operating with agency and the like. And so relying upon post facto regulation isn't going to give us the needed real-time governance. And so what we know from establishing technology is that standards are very important. The standards based upon emerging technology working together amongst the industry partners to see how we can develop this is called out in the AI Act to some degree and the executive order. But let me put a little fine point on this topic of what is an international standard and how does it relate to innovation. So in particular, we want to talk about international open consensus standards. These are specifications that the best of them are based on implementations, that is based on running code, and they capture what the implementations do or should do without going into the details of how it's done. And those then are brought into an open consensus forum where all parties have a chance to discuss what those standards should say and require. Consortia and foundations like the Spatial Web Foundation are critical to the development of the specifications and the running code that play well together. and then working with organizations like IEEE and ISO and IEC to get them promulgated around the globe in an official fashion. The focus, though, here is about getting those standards, in particular the socio-technical standards, connected up with the implementation standards around real-time governance. And so when we talk about agents operating in this network, they're performing activities, we need language, we need standards, we need code for things like certification, norms, laws, contract. How do things run? You know, how do we implement law as code, for example? I think others will talk more about that. But those are the key things now from a foundation consortia point of view, is how do we work together to get the standards established based upon the implementation that allows us to regulate real-time networks of AI agents embodied in the world.
Capum, I want to toss this question back to you, this concept of regulating people, regulating technology itself, or the network upon which it sits. In your role as a technologist in this space, I mean, where do you see it being all three is really how public policy is going to head? Or is it more of a, to George's point, we need these open standards upon which technology is built, and then from there, the rest will take care of itself, similar to how we've seen other technologies advance?
Yeah, like I said before, I think it really depends on the industry and the use case. Some things are very risky, some things are not, right? And so that's the first thing you have to look at. And so I think creating working groups around particular industries to make those decisions, along with government regulators and the public input, is really important. That's why we have these kind of forums like this today. And so the network that it sits on is obviously very vital. The current network, the current internet today, has a lot of challenges with it. Obviously, you know, security and privacy are main concerns. And so there needs to be a lot to be done to be able to shore that up, especially with, like, you know, quantum computing coming down the line. At some point in time, all of the encryption could be resolved by quantum computing potentially. So there's just some infrastructure kind of things that need to be aware of in the future. And then the technology side. So when you say technology, obviously you're thinking, you know, of AI, AGI, autonomous vehicles, you know, robots, all these things that are coming into the ecosystem of the spatial web. Again, that's a really industry specific kind of challenge. And I think every one of those needs to address that. You know, we are launching, and we'll talk about this a little more later, but you know, in some of the areas that really focus on, like, autonomous vehicles, for example, really understanding what each technology capability brings, what are the protocols of communication that it needs, what kind of infrastructure and network connectivity does it need, and then what people are actually occupying that, you know, whether they're the customers that are, or the people that are in a transportation environment and need mobility and moving around, or the people who are working on and designing those systems or designing the AI. You need to take all this into consideration.
Philippe, I want to bring it to you to wrap up this thematic discussion. People versus technology versus network. You know, where do you sit in your viewpoint? And before you answer that, I did just want to let everybody know in the audience, feel free to populate questions in the Q&A box, and we'll address them throughout. You don't have to wait till the end. So Philippe, your thoughts on this thematic, not battle per se, but this debate about what's the proper pathway forward in the immediate and in the future?
So it's very interesting to step a little bit back and look at law in general, where so far legislation has been written for humans and by humans, right? So we're finding ourselves right now in a situation where we're trying to regulate AIs and things using legislation, using words, right? Because we as humans talk in words. And when you look at the future, we're going to be getting at some point to a governance model that requires taking into account AIs engaging and working with other AIs. And if you backtrack a little bit and look at the numbers, you have 8 billion people on the planet today, half of which are active. You have 15 billion IoT devices connected to the internet, going to 30 towards 2030. There is no possibility for humans to manage this type of complexity. So it is important today, and this is what the Spatial Web Foundation standards do very well. They do two things very well. The first thing is they set up a modeling language that explains to machines the world the way we understand it. So basically, it allows us to define rules and policies as to who has the right to do what, where, when, and how, for how long, and in which context. And it allows us also to encode, and this is something that Kaplan will touch on a bit later, policies into the network itself and make it compliant and enforceable, explainable, and auditable. So legislating or writing legislation for humans, for developers, for companies, and around data is very important. But going forward, we really need to look at how to regulate the network itself.
So I wanted to pick up on this discussion about standards, because I think depending on what hat you're wearing, the debate can often get lost around developing policies or governance. When you're an organization, a company, looking at whether it's appropriate for you to deploy AI or develop your own AI, you're often thinking about, well, how do I develop an acceptable use policy? How do I develop a responsible approach to AI that aligns with the regulatory pressures and challenges that I'm getting from the US or from global regulators? When you're a policymaker in the US, at the state, local, even at the federal level, you're thinking, well, what type of framework should we adopt to regulate certain industry? Captain, to your point, healthcare may have a different focus than finance, than employment. But buried within all of these debates, we're seeing a reference to the development of international standards. That seems to be the buzzword. I think we first saw it, or at least mostly we saw it in May when the G7 issued their joint communique calling for the development of international standards. We saw a reference to it in the White House's executive order calling on NIST to work together with international partners to help further the development of international standards. George, I want to bring it back to you, since you are our resident standards expert, and I know you're heavily involved in NIST, which, for those unfamiliar, is the National Institute for Standards and Technology, which is an arm of the U.S. Department of Commerce. NIST is heavily involved in developing industry standards, although they're primarily meant for the federal government on the U.S. side. NIST famously developed the 2014 Cybersecurity Risk Management Framework, the Privacy Risk Management Framework, and in July of this year, they released their AI Risk Management Framework. So NIST has been at the leading edge on the US side of developing guidelines. But George, I wanted to bring it back to you to unpack a little bit. What is meant when we see in the headlines, when we see in the executive order, a reference to international standards? I know you've touched on it a little bit about what you're working on at the IEEE, but hoping you could also unpack, what is NIST doing in this space? What's the IEEE doing? What's their mandate? And are there other bodies working on these international standards to develop operational guidelines for deployers and developers?
Yeah, thanks, Peter. So yeah, this notion of international standards, and here when we talk about standards, we're talking about specifying the concepts that make up what we all want to and need to agree on, is the terminology and the requirements and the way we think about this new technology. Sometimes you end up with a standard that is the running thing itself. It used to be that the meter in Paris, the physical prototype meter, was the standard. And now it is a certain number of wavelengths, a certain emission of light that make up the definition of what a standard is. So that ladder now is a concept that establishes what the standard is. Previously, it was the implementation was the standard. So similarly, with AI, we could point to some really, incredible implementations and say that's the standard, and everybody should build to that standard. But what's a more innovative way, a more open way, a way in which will enable society to move forward more broadly, is this notion of international standards as open consensus specifications, specifying what the item should do. In this case, it's AI. And we're doing that in the Spatial Web Foundation in a couple of ways. One is these socio-technical standards, that relate to the objectives of society with respect to AI and how it needs to define things like norms and contracts in code, and then implementation standards like HSML for the modeling language and HSTP for the protocol. So that's what we're doing in SWIFT. We want to work with organizations like we are working with organizations like IEEE and NIST. So IEEE, for example, we're contributing the SWIFT specifications to that international standardization process that IEEE maintains, getting them promulgated around the world. The NIST process with respect to open standards was really kind of kicked off with the executive order a few months ago by the White House. It says NIST shall establish guidelines and best practices with the aim of promoting consensus industry standards. So NIST is responsible now to establish guidelines and best practices. They're responsible to gather people together and establish what they see as best practices, let's say. And then to put those forward to the open consensus organizations like IEEE, like ISO, like IEC for international standardization. To do that, NIST has now kicked off a AI Safety Institute and a consortium, opening up the activity to folks who want to be involved. And so that institute and its consortium will, over the next few months, then develop these guidelines and best practices from this point of view. They do a very good job at this, and then promoting them as international standards. And so we in the Spatial Web Foundation look forward to contributing to the NIST activities as well.
George, are there others involved in this effort outside of NIST and IEEE? For example, I saw that the UN has now appointed an advisory group on AI risk. There's also talk about ISO developing certain standards. I'm wondering if you could comment on some of those other headlines that we see using the word standard or technical standards. Are they playing in the same space, or is what NIST and IEEE doing something completely separate?
No, it's all tightly, or at least loosely coupled. Everybody's aware of what's going on and have been down these paths many times before with respect to the coordination of this development of the technical infrastructure. Some organizations are more focused on the implementations. Some are more focused on the international policy realms. And so UN or UN chartered activities like ISO, IEC, are very much where this will end up in some fashion being governed by those standards, will have that international cachet as international standards with a capital I and a capital S. In particular, in ISO and IEC is a Joint Technical Committee, number one, their subcommittee 24, which is about AI standards. And it's in particular, I was referencing earlier, that JTC1 definition for AI and the framework foundational document there for defining AIs as agents with goals is a really good accumulation of information they have picked up from around the globe and codified as an international standard. It takes time to do that. It needs to be based on implementation. And it's these other organizations like IEEE and NIST and the SWIFT that bring that implementation to really make the technology work through standards, open standards.
So George, Philippe Capum, a couple questions have come in since we've opened up this discussion on the development of standards. One repeated question is this IEEE standard that we're talking about, the spatial web standards, the socio-technical standards, when are they actually going to be released? That's question number one, which I know is the million-dollar question. The second question is, how do you, let's say the IEEE adopts this standard that we're talking about, that is more open source, open standard, open consortium standard, promotes transparency, promotes explainability. How do you put what's already been released in that box? So for example, all of the LLMs that have been developed that are commercially available, that companies have spent billions of dollars investing in, the IEEE standard gets developed. Is there a marrying of the two? Do folks have to start over? I mean, where do you guys see that interplay occurring?
Maybe I take the more procedural stuff about time and the like, and Philippe and Capum, the coordination aspect of that. So the question about when will the IEEE spatial web standard be available was, I think, a precise question somebody asked. Within the working group, we've got a version 2 already established. And we're moving to a version 3, a draft version 3, internal to the working group in February. Anybody can join the IEEE working group, no cost involved. Anybody can join, get involved. I encourage you to do a web search on IEEE Spatial Web and join the working group. That then draft approved by the working group will go through the IEEE process of promulgation as an international standard during the course of next year. And one of the key things for us to have confidence in moving forward with that is that we're doing the due diligence right now to look at the existing AIs out there and the socio-technical aspects of AI and getting them into the standards now before adoption. But we know we're going to have to wring it out with further testing over the course of the next year. Test beds and the like, sandbox is critical.
Philippe, where do you see that debate landing?
Yeah, well, in terms of the question, like, what do you do with the existing AIs and different approaches that are out there? So if the spatial web was to have its way, you know, to where that we're putting this out there, within the spatial web, we have this concept of TIPS. So TIP stands for trust, interoperability, privacy, and security. So everything that is connecting to the spatial web, you can grade on those 4 different criterias. So trust is like, you know, how accurate is it? Do you know what it's actually doing? Is it introspectable? Can you really interrogate it? Interoperability, do we speak the same language here? Are we trying to achieve the same kind of goals? Privacy, what kind of data do I need to give you access to? What kind of data can you get from me? And security, obviously, you know, what can you do any harm to me? And so any sort of outside service or agent that you're going to connect to the spatial web, you should know what that score is. Just as, like, you know, if you're going to do business with somebody, you want to find out ahead of time if they're good to do business with. And so when you are applying to do things in AI or across the spatial web, you can assess your level of risk for that. So if it's something that is low risk, and then you're not so concerned with the, you know, the TIP score, but it's something very high risk, and you want to make sure that it is very secure, very trustworthy, very interoperable for whatever you're trying to do. And so that kind of credentialized approach of knowing who it is that you're interacting with out there, you really keep it safe. I think that's really important and key. And if there are challenges, you know, a big part of the current challenge with approaches to AI is that when there are mistakes that are made or answers that are given in a racket, it's really hard to figure out why that is. And so if you're going to be in a situation where this is something that's very risky or secure, like say autonomous cars, if there's a mistake, you really have to know why it made that decision. So I think for anything that's a higher risk, that's a really key kind of concern that we have to address.
Philippe, I wanted to bring it over to you to where you see this timeline sitting on. We've got this international effort underway to create open standards. There are open working groups and consortiums gathering information. At the same time, though, we have AI being released in the wild, let's say, and being deployed with a lot of investment. How does, I guess, let me ask you, how do policymakers balance that approach? I mean, we have the IEEE standard get adopted. Does the European Union say, wait, full stop, everybody's got to be on the IEEE standard if you want to be permitted in the EU? Or is it going to be more of an iterative process?
So a couple of points to that. Thank you, Peter. The approach will necessarily be iterative, and for various reasons. First of all, the pace of legislation is by design slower than the pace of technology, right? And so what happened right now, for example, with the EU AI Act is that the European Commission encourages all the players to start abiding as best as possible by the rules that have been set forward in the AI Pact, for example, right? So that's one way of trying to solve the problem. The other interesting piece is that legislation will be confronted with new complications that will arise from the nature of the activities that are being used that will use AI. So I'll give you an example. In the autonomous drone example that we deployed in Europe, there's the notion of explicit versus implicit legislation. So when you're saying a drone needs to fly safely, how do you define safely? So legislation needs to start to get more explicit in its definition when it comes to AI. So there's a great opportunity for legislation to rethink the way it's writing law. So that's one aspect. I mentioned the iterative process. There will come a situation where you will have an adaptive back and forth between legislators and implementations of AI, because some situations will arise where explicit legislation does not exist. I'll give you another drone example where there is no legislation today that explains or that defines, if you're flying 5 or 10 or 15 or 30 or 100 different drones simultaneously, what is the minimum safe distance? How does a swarm of drones operate? Right. So that back and forth will be necessary. The good news is the autonomy and the deployment of AIs is a decision that humans will do. Right. So it's and the guidelines given by the EU AI Act gives a first compass of where to, which AIs to be wary of and which to be less wary of. Now, in the report and in the Future of AI Governance report, we've built another compass for trust in autonomous systems. That is the AIS International Rating System, right? So it's the Autonomous Intelligence System categorization, where we classify in the same way that we've done this that it's been done in the automotive industry, where you have AIs that have different levels of autonomy, different levels of intelligence, and different levels of governing models, right? So you start putting AIs in those different boxes, and then those need to kind of work together. So there's this adaptivity and forward-looking approach that needs to be taken for sure.
Yeah, and I think I'd like to unpack a little bit of what you guys did in Europe and this idea of writing law in a different way, because it seems to me, as the single lawyer on this webinar, that obviously lawyers and regulators, we want clarity. We want a clear pathway to understand what is permissible and what is not. And when you look at the EU AI Act, it's very much at a categorical level. To your point, Philippe, it's high level, saying if you are engaged in a certain activity, it's a no-go, or it is a go, but you need further testing or further assessments. And I think what we're talking about here is a level even at more detail below that. So once you are past that high level go or no go on the particular use case, you then have to get down to, well, if you have multiple agents operating in a permissible space, how do you then regulate their operation? How do you communicate to them as a regulator beyond just the categorical approach, but really at the granular ins and outs? These agents are going to be operating in the physical space and in the digital space. And so maybe this is a great time to show a little bit of the video, because I think, Brian, if you want to pull it up, I think this video that you guys put together about law as code sort of encapsulates this issue, which is how do you take this idea of a spatial web standard in a very contextual environment, flying drones, and what does that look like in terms of taking the law and translating it into managing the agent? So Philippe Capum, I don't know if you wanted to do any more introduction other than that before we showed the video about the context about the European project, but I thought this video always helps sort of put a visual to what we're talking about.
Why don't we watch the video, and then I can share a couple comments afterwards.
When autonomous machines, like drones, vehicles, and robots, operate in the world, their behavior needs to be governed by the laws of the land. However, there's been no way to translate legal text into machine-readable code, so that autonomous systems can operate under the most up-to-date legislation. Until now. Hyperspatial Modeling Language, or HSML, is a spatial web standard, developed at the IEEE. Think of it as a common language that enables AI to model the relationships between people, places, things, and activities. This language is transmitted by the Hyperspatial Transaction Protocol, or HSTP, a universal, secure, and verifiable protocol for communicating HSML between digital and physical systems. With these new standards, legal, physical, and societal policies can be converted into machine-readable, machine-executable, and machine-shareable code. At the European Union's Flying Forward 2020 project, self-governing drones using spatial web standards and Verse's cognitive computing platform successfully flew their mission in compliance with regional laws and policies. Let's explore how HSML enables AI-powered drones to understand and abide by the laws of the land. This process begins with syntactic parsing and pattern recognition, which identifies time, activities, users, domains, and space in unstructured legal text. The HSML output, transmitted with HSTP, is what enables the AI system to direct the behavior of a drone in real time. Geofencing, waypoints planning, and dynamic routing facilitate the creation of flight corridors, no-fly zones, and other constraints. Weather conditions, physical obstacles, and legal policies such as maximum altitude, speed limits, and validated flying credentials are accounted for in real time. Flying Forward has been considered a landmark success, setting the stage for all types of AI-powered autonomous vehicles to one day self-govern. Spatial web standards, like HSML and HSDP, enable compliance to be built into the network, allowing machines to align with our laws and principles in both the digital and the physical world. To learn more, visit www.verses.ai and download our landmark report on the future of AI governance.
All right, so Kappa, maybe you could give us some more context about this project that you guys did in Europe, but more importantly, I think getting back on this standards issue, how this actually operates, conveying legal text into the machine using the HSML, HSTP open consortium standard, George, that you articulated. This is sort of a real life application of what that looks like.
Yeah, that was such a great and fun project to be a part of. It's a 3-year project. We just finished it this year. It's 5 different countries and cities across Europe, demonstrating use cases using autonomous drones. And so these drones were completely flying on their own. We gave them the ground rules. We told them the laws that they adhere to, and they did things like delivering things, doing inspection, doing security. And one of the, just to tell a story about this, one of the ways we actually saw this really in practice, when we went to Zaragoza, Spain, they had a big festival with 250,000 people that came. And we were working with the local fire department. At the last minute, the king of Spain decided to come to the festival. And suddenly the federal government was all over what we were doing with drones. And so we had to make them comfortable and confident that we were able to do, to adhere to the local laws. And so we adjusted everything according to the regulations. The federal government came in, looked at it, approved it. So we're flying multiple drones with helicopters and aircraft all within the same airspace over a crowd of 250,000 people. And it was a great success. So that's the kind of adaptability and regulatory compliance that you need to adhere to. That's still quite a small scale. And if we're really talking about, as Philippe was talking about, swarms of drones or swarms of cars in the future, how do you actually get all of these autonomous agents to work together collectively towards a common goal safely? And that's very, very challenging, especially to try to make sure that everyone is adhering to the same kind of standards and protocols. And so that's where I think something like the spatial web is really necessary to get, like, let's take, autonomous cars, for example. If you have a bunch of autonomous cars driving down the road, how are they all communicating with each other? What are they sharing with each other? What is the data that they're sharing with each other? And let's, for example, if a deer suddenly jumps out of the road, how do they all know and alert each other that there's a new obstacle there and they all move around it safely? These are the kinds of things that we need to be able to address. And so you can get these individual agents working as larger collectives. And that's really where that the goal of AGI becomes really, aspirational, where you get not only like individual agents that are acting with autonomy really, safely and smartly, but get them in the larger collectives, almost acting kind of like humans do, but, better for the betterment of society using AI.
Yeah, a question came in, Capim, as you were just explaining that, about this report that we co-wrote and published in July, The Future of AI Global Governance, which really was the Kickstarter to this Future of AI Governance webinar series. And in the paper, we go into great detail about the development of these IEEE standards and some of these societal issues. And one of the questions that came in said, is your report still relevant? in light of all these developments since July. And it actually is, because even though we have developments like the EU AI Act and the White House executive order, getting back to that thematic point, a lot of those are still discussing regulating people, somewhat regulating technology, still not yet talking about the network upon which information is going to be transacted. And this type of concept of transmitting information over a protocol and who the gatekeepers are, that part of the discussion is still very much a live one. And with that, Philippe and George, I wanted to bring it back to you to wrap up our discussion here about what's next from a public policy standpoint. So let's assume the IEEE standard, the socio-technical standards that you all are working on become adopted, become an open standard that can be leveraged. We talk a little bit about this in the paper, but I wanted to really flesh it out here. How do you see public policymakers, private industry getting together in these regulatory sandboxes that are being now discussed openly by the US government, by the EU, by the Bletchley Declaration out of the UK, this idea of actually getting in a sandbox and testing out concepts, testing out guardrails? Where do you see that effort, testing out the guardrails, and the IEEE standards sort of merging? What's the future state look like in the next, let's say, 6 months to 12 months in actually adopting the IEEE standard in real life, in public policy?
So Peter, I think this is a great question, because at the end of the day, what's happening right now is, or when you look at the standards in general, more often than not, when a standard is developed, it's a document, and then it's up to whoever picks up the standard to kind of figure it out. In this instance, what we believe is important to do is to foster public-private partnerships and test out things, because these standards are technological tools today that we're providing policymakers and players on the market to be able to govern the behavior of AIs, right? So right now there's a lot of conversation about what should be done. Now, operationally speaking, standards are interesting to consider as a how to do it. And so building, for example, we're launching a project called the Prometheus project, where we're inviting public players and private players to come and test out these standards in their specific domains, because these tools that we're providing with the Spatial Web Foundation to the market is something that the market needs to pick up and adapt to their own specific domains, whether autonomous vehicles, whether smart cities, and the rest. And I think it cannot be a one-sided approach. There needs to be collaboration and experimentation and testing and validation, and this is key, because legislators are going to learn a lot, and companies and private and public players are also going to learn a lot, in the same way that we did in this European project, and continue fostering the development of these tools.
I wanted to, George, come to you with maybe a provocative question that has been sort of weighing in this discussion, and that is, let's assume the protocol is adopted, and you have a single government. Let's say, take the government of Spain, Capum, and the King of Spain. Although a nice humble brag, rubbing shoulders with the King of Spain. I like that name. But let's say we take a single government, and now they've got the keys to the protocol, the network upon which all AI is going to sit. And they can give green light, red light based on alignment with the IEEE standard. Are you transmitting language and information appropriately? That gives an awful lot of power into a centralized authority. And we presume it's going to be used for good, but oftentimes can be used for the adverse, as with any technology. How do you see that threat as a real threat with this type of protocol, where we have a standard that could be used as a gatekeeping measure versus allowing the marketplace to take a more market-driven approach? I mean, where do you see, George, that debate sitting?
Well, and so your question gets after this kind of safety and trustworthiness and the like of this network of AIs. And so what we're undertaking here is a development of technology, a maturation of technology, which we know occurs over time. We're going through a series of levels of technology maturation, if you will. Currently, we're pretty low on these levels of maturity, quite frankly, where we've got some prototype implementations. We can see the promise of that technology, but we also know we don't fully understand it in a common way, and we know there might be some risks associated with that. And we need to specify what's acceptable behavior, what's common language for describing the behavior. And so that's what needs to be when you say, just wave a wand and make the protocol adopted. It's really more about this evolution of it, implementation, understanding what it requires, and then in upping enforcement, as we all understand, to avoid bad actors. And so how does that play out? It plays out in the sense of, once we have a common understanding, we have the modeling language, we have the protocol, we have the rating system that was also spoken of, and we can begin to certify that agents are capable of doing certain activities. And so within this network, not only are there regulations that say, you need to certify that your agent is SWIFT compliant or UL compliant, whoever is doing the certification. But it also is about that an agent working with another agent can assess whether or not they trust that other agent and whether they're going to perform safely. So not only is it from an external point of view, regulation requiring it, it's also going to be this complex adaptive system of agents working together at various levels of intelligence to understand and self-regulate in a kind of free energy principle kind of way that minimizes surprise for what we see in this AI, embodied AI in the network of the spatial web. I really look forward to being involved.
Well, with that, I know we're just about up on time. I did want to do a little around the horn here for some key takeaways for the participants in the webinar. And thank you, everyone, for sticking with us over the hour. As you can probably tell, we could probably spend all day talking about these issues. 1 hour is definitely not enough. But Capum, I want to start with you because you're where we began in this discussion. What are some of the key takeaways you have for folks on the webinar?
Well, I mean, I listened to us talk, and it sounds a little kind of scary and dystopic, and that could be one of the takeaways. But actually, what gets me really excited is that we're on the precipice of being able to resolve a lot of the world's challenges. If we can get this right, if we can actually become more interoperable and understand what different needs are across companies, across societies, across people, be able to address those, whether that's climate change, supply chain, transportation, healthcare, education. I mean, we have a real opportunity here to get this right. And so I think that's really the hope and the promise of AI and AGI. And so I'm really excited. Let's take the time, let's be really sure-footed, let's get this right and really benefit humanity.
Philippe, over to you. What are some of your key takeaways?
So I'd like to piggyback on the notion of ecosystem of intelligence, because right now we're talking a lot about governing an algorithm or a type of AI. Where we want to go, we want AI to be autonomous, right? We want autonomy because by having that autonomy to a certain extent, we will be able to solve problems, to Capum's point, that we can't solve today. And so the standards, the social technical standards, are a very good foundation to be able to allow that ecosystem of intelligence to manifest itself in a way that respects and aligns with our ethics and our policies and the rules and the way we want it to be, we want the network to behave. So I think it's a great step forward. It's a step that's going to require a collective effort, obviously, but it's a solid foundation. It's an actual pragmatic tool that we can start implementing actually now.
George, over to you. You've got 30 seconds here since we're out of
Sure
time.
thing. I mean, we are really right in the heart of the development of this AI ecosystem that we've described. And it promises to be tremendous. As an engineer, I have an ethical obligation to make sure that we, work in the right way to make sure this technology meets humanity's needs in a safe and trustworthy fashion. So I say, come join us in the IEEE working group and the Spatial Web Foundation. We've got a lot of work to do.
And I will leave with these thoughts, which is, if you're an organization looking to leverage AI, this can seem very overwhelming, this type of discussion about standards and the future of AI. start small, take baby steps, understand your risk profile. You can implement AI today in a responsible way, and then also be part of this global conversation moving forward. So Capum, Philippe, George, thank you very much for spending time with us. Thank you all for joining on the webinar. I hope you found it useful. If you want to learn more about what we've discussed, you can check out the Future of AI Governance report on each of our respective websites. And with that, thank you very much, and we hope you'll join us next time. Have a great one.
Thank you, Peter.
Thanks, Peter.
Thank you, Peter.